Hey guys, welcome back. Mr. Martin. More math videos. I know you're probably tired by now, but you made it through. This is the final section of our unit, 11.4, completing the square. So, our objective for this one, today I will be able to use the completing the square method. Okay, completing the square method. It's actually going to do two different things for us. We're going to convert to vertex form, which we've done, but I'm going to show you a new method. And it's going to help us solve quadratics. Remember, that's the name of the game for this unit, is solving quadratics. Alright, so this one should be really short. I don't have that many examples for you. It's just a matter of getting that practice in. Alright, so our things to know. Okay, I went ahead and printed this for you. You guys don't have to write these down, but kind of read along with me as I'm talking about it. Completing the square helps us do several things, and there is kind of a nice little visual. We can do this activity when I get back. But there's if you had a square and you had a piece missing, we can add a piece in to complete the square. That's basically what we're doing. If we wanted to visually represent this, we could use some kind of blocks and do all that stuff. But for the most part, we're going to use it to solve a quadratic equation. Oh, and this should say vertex form. Man, I went this far without a typo. Yes, this should say vertex form. Okay, so that's the second thing that we can do with it. We can put it into vertex form. And there's this other thing called conic sections. You're not really going to see this till Algebra 2 and pre-calc, so we're not really going to go over it in this video. Alright, these are things we should already know. We should know the standard form looks like this. We've been talking about it. Vertex form looks like this. We've also been talking about it, and we know that h comma k is our vertex. When we use the calculator, we know that the zeros are the values for the x in a quadratic. Okay, these are our x-intercepts. We've also known this from the zero product rule. And we've solved by square rooting. You're going to need this after you complete the square. So remember to use your plus or minus. That is huge. Plus or minus. Let's see here. Things that we're going to learn in this lesson. We're going to do something called finding the new C term. Let me highlight that right here. Okay. And we have a formula here, and I know it's confusing because it looks a lot like negative b over 2a, but it is not the same as negative b over 2a. So you're just going to have to remember this. This is just your b term divided by 2, right? Which is also the same thing as saying 1/2 of your b term, and then we're going to square it, okay? And then the other thing that you will learn is how to write the perfect square quadratic as a binomial squared. We're going to need this in order to do the solve by square rooting part. Okay, so very important that you understand what this piece is here moving forward. Alright, so I got two examples because the steps are written out for you step by step, so we don't need to run through a bunch of these. You should be able to get through the homework using the two examples that we go through on the notes. Alright, so our first example here, I want you to take note of what this says up top. These are the steps to completing the square when your answer is not a radical. So this means you're going to end up with some kind of whole number or maybe a fraction, but it is not going to have a square root. Okay? So the first step says set your equation up like this form to the right. You may need to move some terms around. Okay, I'm gonna just put this here. Remember, in standard form we always do something like this, right? This is our standard form. What we want to do for completing the square is, this is not really to the right, it's kind of below, but you know what I mean. We want ax squared, so our a term plus our b term, okay, And then we want our C term to be over here. Okay, so from the original equation, we want to always move our C term to the right, and we want to leave ourselves some space here, because if you look at step 2, we're going to write in a new C term. Okay, so let's go ahead and do this part first. I'm gonna try and color code these for you guys so it looks a little bit easier on the eyes. So we have our A term, our B term, and our C term. We want to move our C term originally to the right. Sometimes you might get a quadratic where it's already on the right, and you can just leave it at that. We want this to look like this before we find our new C term. So in our example here, we have a negative 48. So I want to add a 48 to both sides. And that will give me x squared plus 2x. And remember, I want this space right here. And then I'm going to have this positive 48 to the right. Okay, so that's step 1. Step 2, it says we need to write a new C term using this formula here. And this is the one that we put on this little section right here. This is that b over 2 squared. Okay, so we're going to have the b over 2 squared. I'm going to write that here. But I'm going to show you how it works right here. We're going to do this part in green. So we have our A value and our B value. Let's go ahead and maybe just label these for those of us that like to label them. We got A is 1 and B is a positive 2. So we want to set this up just like this. And I'm going to show you a little trick also that will be helpful in doing these. So we have our B value, which is positive 2. And we're going to put this over 2. Okay. But before I square it, I want to simplify this fraction because I don't want to have to square a fraction, right? We know how to do that. We've learned our exponent rules. Okay. So I'm going to do this. I'm going to simplify this. And I want you to take note of our sign too. Right here we have a positive 2 divided by a positive 2. Normally I wouldn't write a positive right here. But for this section I'm going to do that. 2 over 2 gives me a 1. Okay, then I'm going to put the squared right here. I'm going to square this term, and 1 squared is going to equal a positive 1. Okay, and the reason that I'm doing this, you'll see as I go through the steps, I'm going to circle back to this part right here. Okay, but for now, we found our new C term. This is the new C term right here. So new C term. Okay. So we can check this one off. Now it says to plug your B value into the formula from step 2 and evaluate. That's what we did right here. Okay. Step 4, add the new C term you got to both sides of your equation. Okay. So I'll do this part in green still. We found out that our new C term was a positive 1. Okay. And it's always going to be positive because even if you have a negative in here, what happens when you square it? You're going to get a positive. So I'm going to add a 1 to both sides. It's critical that you do it to both sides. Okay, so now I added the 1 to both sides. That's step 4. Check. Now it tells me to factor the left side of the equation and combine your like terms on the right side of the equation. So let's go ahead and pull back our factoring skills. Remember, if we have a plus plus, we're going to need 2 binomials that are plus and plus. And we need 2 values that multiply to 1 that add up to a 2. In this case, our factors of 1 are just 1. So, that kind of looks like a C. We got 1 and 1. Okay, and then it says to also combine our terms on the right side. So this gives us a 49. All right, let's slide down a little bit. We checked off step 5. Looking at number 6, it says since both binomials are the same, it wants you to write it as one binomial squared. Remember, if it's a perfect square binomial, this is the same as this. We can simply write it as 1, and we can square it. And then we set this equal to 49. Okay, so I want to go back to this part right here. The reason I had you do this fraction and then write it the simplified form and then square it is because if you look, here we had a positive 1. This part is a positive 1. So you don't actually need to figure out how to factor this part. You can kind of skip this step. Once we're here, we can say, oh, this was my new C term. I know that's going to be part of my perfect square binomial. Okay, and you'll see on the next example how that works. So now that we got the x squared, or x plus 1 squared equals 49, okay, it tells us in step 7, all right, we check that one off, square root both sides, and don't forget your plus minus. So I'm going to do this in purple. We're going to square root both sides. Here we have the whole quantity of x plus 1 being squared, so when we square root this, we're going to get rid of just that 2. Remember, this was from our solve by square root section. And then the square root of 49 is a plus or minus 7. Okay? So step number 7 complete. Now we're down to where we have 2 equations that we need to solve. Running out of colors, so I'll do this in black. So we got x plus 1 is equal to a positive 7. And we also have x plus 1 is equal to a negative 7. Now let's just go ahead and solve. We got a positive 1. We subtract a 1 from both sides. We get x is equal to 6. And we subtract a 1 from both sides, and we get x is equal to negative 8 with our solution set looking as such. Alright, not too bad, huh? Well, I didn't think so. Hopefully this went smooth for you. Remember, I got tons of practice for you guys to do, and like any other kind of math, these will just take a little bit of time. Alright, so I have one last example for us, and this is our steps to completing the square when our answer is a radical. So if you can see here, all of our steps are the same, except we have one extra little spot right here. Alright, so let's go through this together. Remember, we want our form to look like this. We want our ax squared plus bx, and we want our c term to the right. So if you look at our example, we do have a value on the right, and we have a c term here. We just want to simply move that over. So the opposite of a negative 9 is a positive 9. We're going to add that to both sides, and we get x squared minus 4x. Leave your space, and negative 5 plus 9 is going to give me a positive 4. Alright, we want to do our new c term. Okay, so this is our step 2 and 3 kind of combine. Alright, let's take our b value, right, which is a negative 4. We're going to put that over 2. Remember, I don't want to square it yet. I want to kind of see this little cheat sheet part. Negative 4 divided by 2 is a negative 2. Then I'm going to square it, and then that is going to give me a positive 4. And then it tells me to add my new c term to both sides of the equation. Here, let's check these off since we've finished these steps. So I'm going to add this to both sides. I'll do this part in green. We have a positive 4. That, yeah, I know you're like, oh, there go those 4s again. Positive 4. So I'm going to add this 4 to both sides. Okay. So remember, this is that little cheat sheet part for the next side, or the next step rather. I don't really need to factor that. I know that I added this 4 to make this a perfect square quadratic. And this is the constant term of my binomial. So instead of having to factor this out, you can if you want. I'm not going to do it. I know that I'm going to be left with an x, and it's always going to be this value before you square it. So this will be a minus 2 squared, and then I'm going to get a 4 plus 4 giving me a positive 8 on this side. So we've got number 5 complete. Alright, now if we look at our next step, since both binomials are the same, right as one binomial squared, we were able to skip that using this little indicator right there. Now it wants us to square root both sides. So I square root this side, I square root this side. I'm going to be left with a x minus 2. And then I got a square root of 8, positive square root of 8. Can I simplify this plus or minus radical 8? I sure can. We know that 4 goes into 8 2 times, so I'm going to have a plus or minus radical 4 times a radical 2, and this will reduce to a plus or minus 2 radical 2. Okay? Now we are at our last step, which tells us, oops, that should have been blue. Let's go to purple for the last one. So now it says write your two equations. So I can simply do that here. I got x minus 2 is equal to a positive 2 radical 2. And I also have x, you know what? Let's draw a line right here so we don't get confused. We also have an x minus 2, and that is equal to the other part, negative 2 radical 2. All right, so to get rid of this negative 2, I need to add 2 to both sides. But remember, this 2 cannot be combined with this 2 because these are not like terms. Right? Like terms need to have the same radicand and the same index, and these do not. So this will simply be x is equal to a positive 2 plus 2 rad 2. And then on this side you add the 2, and you will have x is equal to a positive 2 minus the 2 rad 2. Those are your two solutions, boom and boom. So you can go ahead and put those in a solution set form if you like, or you can go ahead and leave them as two separate answers as x equals x equals. All right, so go ahead, get through the homework. I feel like this is a fairly easy section for you guys. It's just a matter of getting through those steps. So continue to take a look at this little 1 through 8 step list until you no longer need to use it. That is the goal. So go ahead and try that homework. Hope you guys are doing well. Remember, if you have any questions at all, go ahead and shoot me an email. I will be actively checking my student Gmail. And can't wait to see you guys again. So thanks for listening. Peace.